testing the counter. Up, up, up. Project 1 completed. Time signal generation, decoders and inverters working. Project 2 completed. Program counter and arithmetic unit. Counting. Up. Three cycles there. Project 3 completed. Memory access register. One cycle. Program counter. Memory access register. Completed. Random access memory. Right now there is nothing in the address, and we're going to write these three instructions into these three different addresses. So for 0 we have instruction 4, right? And we have 0, 1, 2, 3, 4. Now for address 3, we have 3 here. We're going to write the instruction 8. And 8. And for the address 8, we're going to write the instruction 3. Instruction 3 and address 8. 0, 1, 2, 3. Now we can go back, and for address 0 we have 4. For address 3 we have 8. And for address 8 we have 3. All projects completed. Programming the computer. Only this section is connected. We're going to program these instructions in these addresses. We start with address 0, instruction 7. Programming. Instruction 7. Address 3. Instruction 4. Programming. Instruction 4. And finally address 6. Instruction 1. Computer program. And now we give power to the rest of the computer. We have to first turn this off. This in particular, the addresses must be off. And we start the program. So as soon as we have the first cycle, we should see 0, instruction 7 activated here. This is our clock, and here we can see the whole one cycle running. And we get to the third cycle that's going to be in the address 3. It's going one address at a time. We shall see now this turning on in 4. Basically we have here 4. Okay, so we had to turn this all off because this is connected with the memory, and this is also connected with the memory. So this is what we use to program the computer, so it has to be off while we're using it, so it doesn't interfere two signals at the same time in the same pins. So now we wait there for instructions at the address 6, and here we have instruction 1, and it's all working very well. Thank you very much. Okay, in this video we're going to try using the registers to add, and we'll expect to see the number that they add in these LEDs right here. This for register A and this for register B. So in one cycle we're going to put, since the computer goes into the RAM one address at a time, we're going to go into each address and write an instruction. For the first instruction is going to be just add A until we get to number 2 in the registry A, and then we're going to add B until we get to number 3 in the register B, and then we just do nothing to make sure we finished, and we should have 2 in this one and 3 in this one in binary, of course. So let's go program this. Got provide power. Okay, so 0 0. Okay, so now we go to address B. Instruction 1. Instruction 1. Okay, so we added some instruction B, and now we're going to do the do nothing. So that will be instruction 7. Okay, so let's run the program now. This all needs to be disabled. The registers at the beginning, they're all like this, so the first time you put a value into them, they actually start in 0. Like this. First instruction starts in 0. Now the second instruction is when it adds a value. And we expect this to arrive until number 2 and stay there. And now we should be seeing register B being activated right here. And starts in 0, and let's hope we can get it to number 3 if I wrote the instructions correctly. 1, 2, and 3. Okay, so next instruction, it should be the do nothing instruction. So we should be seeing the instruction 7 here, as it is activated, instruction 7. So now that the cycle repeats, it's going to add 2 in this one, 3 in this one, until we turn it off. Thank you.